Dear friends, we are solving right now exam, which is paper 4, variant 3, October November series 2025. Time allowed for this paper is 75 minutes. Very important to say to you this thing, 75 minutes, and value of G, we will be using 9.8 meters per second square, and marks are 80. So you can imagine 80 marks and time is 75 minutes. It means you have less than a minute per mark. Less than a minute per mark. Very important. So what to do here? I will start with a tip that no panic. You started question number 1, part A, B, C. You did correctly. D, part 2, you are unable to crack it. No problem. Just put a cross on the question that particular part with a pencil. Fold that page. Fold that page or that paper on which the question number D, part 2 is. Move forward. And then keep this practice or a tool till the end of the exam. Then at the end, there will be some time spare, so you can go quickly to all those folded pages which you have folded already, where there were some doubts you were unable to solve. Then waste, take your time or apply your remaining time on those questions. Don't make it a habit that I will solve question number 1 completely, then I will move to 2. Maybe 1D2 part was difficult, and this will be difficult for everybody. So what to do? You move forward. Maybe the next question is quite easy, straightforward, maybe 8 marks, and you are able to do it in 3 minutes. So be very careful and follow in this way, and you will be able to tackle the time. And this time is short. Mostly students are saying it's not short. If it is, let's suppose it is less time. This is not only for Uzair, this is not only for Mr. Sajjad, this is not only for Ahmad Murtada, this is for everybody. This is for everybody. Remember it. Going to the exam, calculator, a good working calculator. Make sure that you are not using it for long time, that during the exam its battery is carbon, its battery is not working, and you are sitting them together. If you have two calculators, just carry two calculators with you. Statement of entry, 2-3 pens, pencil, good scale, lengthy scale, at least 20 centimeter. Maybe you have to plot a graph during the exam, or you have to draw a vector scale diagram. So ready for everything. And if it is hard, let me say it again, it is hard not only for you, for everybody. The curve will go down. If it's very easy, don't be very happy, curve will be very high. So there is a standard. So concentrate. Again, I will repeat today that when you are going to exam, there is panic. Don't drink too much water. Take your full sleep today, like 10. If I am stopping this lesson today 10:30, so 11, 11:30 you are asleep. You are going to sleep so that early morning you can get up again. As I told you, 10 I will be available again, 10 to 11:30, so that we can go for prayer for 1 hour. So 11:30 to 12:30 we will be signing off, and again from 12:30 to 1:30 I will be available for your doubts, whatever the questions, discussion you have, you can discuss with me. Then the definitions, nothing added or minus or subtracted from the definitions which are given to you people. Please write the same wording as you are told, because 50% paper is for everybody, and almost at 80% you are in the line of A or A star. Definitions same way. No new topic you are going to learn now. Whatever you have learned, just keep on revising it. Then not drinking too much water, especially after like 1 or 2 p.m. or like this. Just you are feeling thirsty, of course, pressure of exam, what to do? Few sips of water and khalas, so that job is done. During the exam, your concentration not towards the washroom, your concentration should be towards the exam. These things are very much important, you must remember them. So I will keep on saying. And again, Ali Yusuf, you joined me now, mean a part you are unable to crack, you are unable to understand how to solve it, just put a small cross with a pencil on that part, fold that page, and move forward. Maybe next 3 questions are so easy, so solve them. Then fourth, fifth question, maybe again there is a problem, no problem, cross that particular part, fold the page and solve the paper first. And then in the end, in the remaining time, you can just waste your energy on those papers. If you will be wasting time on that particular question where you are trapped, you are unable to crack or understand to get the lead to solve that question, so you will be getting under pressure, and it will be building up. But if you have done your question paper already 10 minutes earlier or 5 minutes earlier, so then you are confident. Your vision will be better also, even at that moment, vision of understanding. So you can crack or you can get the leads to those particular questions and you can solve them. Now, let's start the question paper. As I told you, this is October-November 2025, paper 4, variant 3. 75 minutes is the time allowed and 9.8 is the value of G, acceleration due to gravity on Earth, and 80 marks are there for the exam, and this is 50% of the curve in your exam for grading system, let me say. Now, a hard ball is dropped vertically downward. That is the question number 1. And you can see here, figure 1.1 shows the speed time graph. Speed time graph. As I told you, I'm not solving only the questions which are being asked. Speed time graph has 2 uses. 1, slope or gradient of the speed time graph that gives us the acceleration. Remember, it gives us what? Acceleration. Lesson is being recorded, don't worry. This is one use, very commonly for 2 marks, sometimes for 3 marks, if you have to draw the tangent line. Use number 2, area under the graph. Which graph? Speed time graph. Area under the graph. I'm not writing the area under graph. That is equal to distance, my dear students. Remember these 2 points. And it can be the area of triangle, 1/2 base into height. It can be the area of rectangles, length into width. It can be the area of square, side by side. It can be the area of trapezium. So 1/2 a plus b times h, that is the area of trapezium, which means 1/2 a plus b. What is a, what is b? 2 parallel sides times the distance between the sides, which is h. Or you can say, you can split that trapezium into 2 parts. One will be rectangle, other one will be triangle. So apply the formula for rectangle and triangle, find the areas, and then add them up together, you will get the distance traveled. So speed time graph has 2 uses. Zain, my dear son, welcome to the class. So there are 2 now uses of this speed time graph. Air resistance is ignored, and we can see air resistance is ignored because graph is a straight line. This gradient is constant. It means acceleration is constant. And if it is all done on Earth, it means the acceleration A is equal to G, and that is, my dear friends, 9.8 meters per second square. And be very careful. See, meter per second, and here time is in second. And in February, March, which is already shared with you people, we have seen that the graph, it was distance time graph. Distance was in kilometers and time was in minutes. And he asked the speed in kilometers per hour. So we are supposed to convert time in minutes to hours by dividing it over 60. So be very careful. First mark the check the units given on the axis so that they are correct, they are system international, or they are according to the answer requirement. Then move forward. Describe the motion of the ball in figure 1.1. I already told you, constant acceleration. And it is only 1 mark, so I'm writing just constant acceleration. If it was 2 marks, what you are going to write? It is moving with constant acceleration because the gradient of the graph is constant. Because the gradient of the graph is what? Gradient of the graph is constant. But here it is only just 1 mark and motion. Show that the distance traveled by the ball is 1.8 meters. Now see, my dear students, I told you already here, 2 uses of speed time graph. Slope or gradient of the graph, acceleration. I wrote ACC. And area under the graph is distance. Now they want that show the area is equal to 1.8 meters. So no worries. So from here, you can come like this. See, it is a triangle. So how we can calculate the distance? Distance is equal to area of the triangle. In exam, even you don't need to write this area of triangle. I'm just writing the triangle sign. You can directly write D is equal to 1/2 times base times height. Then it will be equal to 1/2 times base. See, it is 0.6. Be very careful. 0.6 times height. So see, this line is in between this and this. So this is 4. First of all, let's check what is one small square representing. So 2 minus 0 divided by 10, it will be equal to 0.2. So see, this is 6. It means this point is 5.8 and this one is 5.9 in the center here. So we can write 5.9 for height. So my dear friends, here I'm going to write 5.9, and when I'm multiplying them together, so I'm getting
1.77.
1.77. So write this answer 1.77, and in two significant figures, it will become, of course, 1.8. And don't forget to write meter with it. Don't forget to write meter with it. So, my dear friends, not only the questions, but also we will be solving some discussion related to those points, how the possibilities are there. The mass of the ball is given, that is m. Calculate the gravitational potential energy stored in the ball immediately before it is dropped. Now see, show that the distance traveled by the ball is 1.8. So it means the ball is falling from a height of 1.8 meters. Okay. So what I'm going to do, delta EP, because energy will change. So delta for change, or even you can write mg. More technical approach is delta H. Mass of the ball is not changing. Value of G is not changing. Height is changing. So my dear friends, mass is 0.54. Value of G is 9.8. So it's better I should also use 1.8. All values are two significant figures. So when I'm calculating this all, I'm getting the answer, dear friends, 9.5 joules. So here 9.5 joules. If you will use 1.77, it's okay. Then also write the gravitational potential energy in three significant figures. And see, now I'm doing a mistake. Joule is not written there. So I have to write the unit joules, which is in capital letter J. Which is in what? Capital letter J. Okay, my dear friends, let's move forward. Determine the kinetic energy of the ball when it has fallen half the way to the ground. Half the way to the ground, and only one mark. Now, what to do here? Now, here law of, it is only one mark, and I'm going to write, by the way, I'm going to write EK. First, let me write the answer 1 over 2 times 9.5. And when we are doing so, we are getting the answer, my dear friends. See, 9.5 times 0.5, it comes to be 4.75. 4.75. Let be consistent with two significant figures, so it will be 4.8 joules. Now, why? Why? Law of conservation of energy. This answer is according to law of conservation of energy. That is saying loss in EP, potential energy, is equal to gain in kinetic energy. Why I'm saying like this? There is also sometime loss in potential energy is equal to gain in kinetic energy plus work done against air resistance or friction. But in this case, no air resistance, very clearly mentioned here that air resistance is ignored. So when the ball will be at halfway, it means it has fallen 0.9. 0.9. Total height is 1.8 meters, so it has fallen 0.9 meters. So its gravitational potential energy will be half. So it means half fall in gravitational potential energy will be equal to gain in kinetic energy. So that will be, instead of writing 9.5 joules, we will be writing half of it because it is halfway. So that is 4.75. It is preferred that you should be consistent with your answer with two significant figure here. See the two significant figures here. Now, I'm sure it will be done. Now, 3 marks, and very common question. The same ball is dropped from an aeroplane. Air resistance now is acting on the ball. Explain how the vertical motion of the ball changes from when it is dropped to just before it hits the ground. Use the ideas of forces in your answer, and especially now when the idea of the forces in your answer, very common question and repeated question. When it is the idea of forces, my dear friends, we should be very much consistent with this, that we should be very much consistent with that. There are two forces acting. One is the air resistance, which is vertically upward in this scenario because ball is falling down. Another one is the weight, which is downward. Air resistance magnitude will keep on changing depending on the speed of the ball in this case. If there was a parachutist, so depending on the surface area of the body, like the parachute with the human body, along with the speed. But here it is ball, the surface area of the ball is not changing. So it will be air resistance will be only depending in this case on the speed of the ball. So these two forces. Now, first of all, we can answer this, but I will be writing here three steps. First of all, to explain this, see, when the ball is dropped from the aeroplane, only weight is acting on it. Air resistance will be zero because air resistance is directly proportional to speed. So when the aeroplane is flying horizontally, he's asking vertical along y-axis. So speed is zero. So here the resultant force is equal to weight, and it means acceleration is equal to g. It means what? Acceleration is equal to g. This is first step. Weight will stay constant alathu. Now step 2. Now, my dear, as the acceleration is there, so ball's weight is still same, but now there will be a small amount of air resistance. Air resistance will be increasing with the speed. Now, what about the resultant force? Resultant force decreases. Why decreases? Because the resultant force now will be equal to weight minus air resistance. Before, there was no air resistance. So this implies that now the acceleration of the ball will be smaller than g. It will be decreased. Then, my dear friends, in the third stage, let me say, a stage will come when the speed of the ball will keep on increasing. So weight downward will be balanced by the air resistance upward. Now, what will be the resultant force, dear friends? It will be equal to weight minus air resistance will be equal to zero. If resultant force is zero, it means acceleration is zero, and body will be falling with what? Constant velocity. So this will be the all scenario. In terms of what? In terms of forces. Wait a minute. I need to say something more also there. Dear friends, sometime in terms of graph, same question in term of graph. See, speed in meters per second. Please be energetic. After 1 hour, I will give you a small break. We will continue long. It is not like same journal paper as I'm solving. I have to explain extra things so that if anything linked is there, so you at least having some knowledge, previous knowledge about that. Now the graph, initially constant acceleration this way, then it will start to decrease, and ultimately it will become this way. For ball, it will be this way. If it was parachute, then it was also going to be this way. And this is for, I'm writing here definitely, this is for parachute. No, better for skydiver. With parachute, of course, he's jumping. So this is for skydiver. But my dear friends, for ball, this graph is for ball. Now, this is the first section, if you ask me, as I explained. This is the second portion, and dear friend, this is the third portion according to this diagram. Okay, now let me write the answer here. If anybody is having any question, feel free. I can sit with you till 12 even. I have no problem today. I'm full of energy, and that's why I gave you also some sort of relaxation. Not started the lesson at 7 or 6:30. I give you a time so that you are free from your exam 4:30, reaching home 5, you got fresh, and now we are in lesson. Now, my dear friends, I will write in three different colors, three different answers. Number one, in the beginning, in the start, please, resultant force on the ball is weight. So ball falls with acceleration A that is equal to G. First mark. Point number 2. As the ball is accelerating, so we will say as the speed of the ball increases, as the speed of the ball increases, please, A dot or air resistance on ball also increases. Air resistance on ball also increases such that a resultant force which is equal to weight minus air resistance decreases and acceleration of ball decreases. So up to the moment you have scored 2 marks. Even if it is coming in exam for 4 marks, we are going with the same fashion. Number 4, number 3, mark number 3, third color. When air resistance balances the weight, resultant force becomes 0. So the ball falls with constant velocity. Even you can say terminal velocity, or even you can say zero acceleration. I'm sure this will be very clear to all of you in terms of graph, in terms of diagram, in terms of forces. And forces you have to mention. A soft ball is dropped by a student so that it bounces on the ground. Figure 1.2 shows the height time graph. It is basically distance time graph. Height time graph means distance time graph. Height is a distance for the ball. The height is measured from the ground. The ball bounces 4 times. Here it is shown. See, 1, 2, 3, and 4. Wait, bounces. So better to say bounces 4 times. So my dear friends, 1, 2, 3, and here it is 4. The ball bounces 4 times. Now what is the question? Explain why the change in height of the ball between B and C is less than the change in height between B. See here, height is this much. And here height is decreased. Why this height is decreased and 2 marks are there than the change in height in A and C. So of course energy lost. So my dear, we can say sum of the energy is transferred is transferred transferred to the ground as thermal energy stored. This is 1 mark. So when this will happen, so gravitational potential energy at C will be smaller than the gravitational potential energy at A. Height is decreased. So the second mark we can say, my dear friend, so EP gravitational potential energy at C is less than, sorry, is less than E A. No, sorry, less than gravitational potential energy at A due to decrease in height. Even you can say there will be less kinetic energy. The ball has less kinetic energy after B because the height is less, so kinetic energy will also be less. Why I'm relating kinetic energy or speed with height? So this is also very important. My dear friends, please remember this one always by the law of conservation of energy. 1 over 2 mv square is equal to mgh. Mean when the body is falling down, height is decreasing, so gravitational potential energy is decreasing, kinetic energy is increasing. So now see, mass is cancelled with mass. So if I'm going to make v square as the subject of equation, it will become 2gh. And take the root on both sides, square root on both sides. So many different things I need to share with you today. So v is equal to what? 2gh root. Now from here, my dear sons and daughters in the lesson, you are given with only height in a question and you are asked to find the speed. Don't worry, just use this rule. And if it is 3 marks, show the proof also. Don't write directly v is equal to 2gh. So say that for no energy losses, for no frictional forces, kinetic energy is equal to like gain in kinetic energy more suitable. Gain in kinetic energy is equal to loss in GPE. Why? Body is falling down, height is decreasing, GPE is decreasing. Body is getting the speed, speeding up, so kinetic energy is increasing. So now, as I told you, so potential energy at C is less than EP at A. Even you can say kinetic energy after B, because kinetic energy just before B will be maximum in this case. Then at position 2 it will be smaller, at position 2 it will be even less than 2, and at 4 even it will be less than 3. The reason, after every bounce the height is decreasing because the energy is being transferred as thermal energy to the ground. Okay, so even you can say sound energy, when it will be hitting the ground, there will be also sound energy which is being wasted, but it's okay, only thermal energy we discussed. Next, my dear sons and daughters, this question is done, and a lot of different things I have explained which were not asked. Now come. A cricket ball is traveling at a speed of this, so speed is given.
Mister,
Yes, Sam. Please speak loudly.
I have a question on the previous question. Can
Which
it be
part,
in
my
terms
dear?
of force?
Your voice is low, my dear son. If you can speak bit loudly.
Uh, can the answer be in terms of force or resultant force?
Answer in B in terms of forces. See,
Not be the other one of the ball,
this
the
one.
height.
Yeah, this one.
Yes, C. Yes.
How will you say force?
The from B to C, the resultant force decreases because the gravity pulling the ball down. Is that correct?
Can be said. You can say for, still force is acting and distance is being moved, so that will be work done. We have to talk about in terms of energies. So height is directly linked with speed, and speed and height both are with energies basically. So preferred answer will be energy.
Okay, thank you.
Yeah. The mass of the ball is given. Now the player catches the ball and ball comes to rest. So final velocity is basically 0, and this is, we can say it as initial velocity. Change in momentum of the ball during the collision. So, change in momentum, delta P, it is equal to mv minus mu. So, better take mass common. So, v minus u. And then, my dear friends, mass is 0.14. V is 0 and u is 25. So, as we simplify this, answer is minus 3.5. So if you want to write minus with your answer, okay. Otherwise here, show it there, but write here simply 3.5 kilogram meters per second. 2 marks. Very simple. Now, this was quite simple. The player's hands are in contact with the moving ball for 9.7. Now, here be very careful. ms. It is not meter second. This is millisecond, which means times 10 raised to power minus 3 seconds. Calculate the horizontal force exerted by her hands to bring the ball to rest. Even you can calculate it by F is equal to ma, but I will use another formula which we are using very commonly, my dear friend, that force is equal to rate of change of momentum, which we are using very commonly in exams. In thermal physics, sometimes they are saying, okay, uh, gas molecules, how the gas molecules exert pressure on the walls of the container in terms of momentum. So we are used to say that gas molecules hit the walls of the balloon or container and rebound such that their momentum is changed. 2 marks. And then we are writing this equation: force is equal to rate of change of momentum, real second law of motion, real form of second law of motion. And then in the end, pressure is equal to force over area. So if force is exerted, pressure is there. Why I'm using this? Because we have already delta P, that is equal to 3.5. And time is 9.7 milliseconds. So we can write 9.7 times 10 raised to power minus 3, or 0.0097. That can also be done. So when we are finding the answer, so I'm writing the rounding of answer, my dear friends. That is equal to 360. Don't forget to write unit, which is Newton. So 3 marks are here. Next, it is done. Question number 2 was quite short. And here also, let me tell you, even there can be a question which I was willing to solve in the previous days, but there was a series of exams started with math, then English, then chemistry, and tomorrow is fourth in a row, that is physics. So that's why I didn't. Otherwise, I have made files particularly block wise. So I was willing. Now there be a question like time of contact is very important. They may ask you how the seat belt are the airbags which are inflated in case of a crash. So why they are useful or how they are useful? So simply, my dear friends, you will say either it is seat belt or the airbag. Even there is a question that a player, baseball player, as the ball comes to the batter was unable to hit the ball, so ball goes to the hands of the wicket keeper or ball keeper standing behind the batsman, or even in cricket. So he holds the ball, and he is holding the ball. Now see my hands, holding the ball, not keeping, moving his hand back like this. So in both the ways, why it is useful? So answer will be, in all these scenarios, the time of contact, the time of impact is increased. Momentum is conserved. So the force acting on the hand, force acting on the body in case of crash, air balloon is inflated, or airbag is inflated, or the seat belt you are using, so it will increase the time of contact. Less force will be acting to conserve the momentum, less injuries, like this. So this concept should be in your mind, repeatedly being asked in exams. Ahmad Murtada is having, yes, Ahmad, my dear son, exactly. You can use F is equal to ma also. So m, and then what will be a? V minus u over t. See, already this v minus u we have done over t. This is their same concept. Even you can use that, not a problem. That's also workable. Okay, let's move forward now. The next question is, this one now, before, this is Sankey diagram. Remember it. Even remember it. Be very careful. Sometimes they can tell you to draw this. The arrow which is pointing straight forward towards right, that is useful work. That is which sort of work? That is useful work. And bending, either downward or upward, they are wasted energies, or in this case, powers. Now, also one thing more. See, power used in power station 40 megawatt, power used in transmission 25 megawatt. And see, this is the least power. The thickness of the arrow is also least here. This is a little bit greater than this one. Useful power output, wasted energy is maximum. See the thickness of the arrow, it maximum. So the thickness, don't make that useful arrow is very thick and the wasted energy arrows are very thin. No, never happens like this. So remember, the thickness of these arrows is also talking about the magnitude of the energy in case of energy or power, like in this case, in terms of power. Remember it. Okay. States show that the useful power output from the transmission is approximately, is the efficiency given? Okay, is approximately 1100 megawatt. And how many marks are there too? Now, my dear friends, it is so simple. What to do? See, input power is given. So input power minus all these wasted powers, powers which are not useful. How do it is written wasted only here? But remember that in a Sankey diagram, all the arrows, either they are showing the energies or powers which are curved downward or upward. They are wasted forms of energies. Nowhere it is written useful with any one of them except this. So, my dear friends, only 2 marks. I'm going to write useful power output. Useful power output is equal to I'm writing the answer directly. In exam, you can write these values also. Power wasted in power station plus power used in power station plus power used in transmission. All you have to write. So now what I'm going to do? Power input minus these all. Power input is how much? Okay, let me write. Power. I'm going to write power input minus power wasted. Okay. So my dear friends, it will be power input is how much? That is 3400 megawatt. So that is how much? 3400 megawatt I will write in the end minus power input. Sorry, power wasted. So they are 2200 megawatt plus 40 plus 25. And here in the end, my dear friend, you can write megawatt. Okay. Now simply let's calculate it. My dear friends, that is 3400 minus in bracket 2200 plus 40 plus 25. Bracket closed, and answer is 1135. So what is the answer? 1135 megawatt. So you can say it equivalent to 1100 megawatt, or even this way it's okay. So please remember the Sankey diagram question that they have brought first time here. Otherwise it was in journal within that. Yes, Zen, you are right. Calculate the efficiency of the power station. That's quite simple. Write the formula for efficiency, that is useful output energy over total, useful output power over total input power, and you will get the answer. Okay. So first of all, write the formula for efficiency. I'm just writing F, but you will write completely in exam, complete spellings. So useful, but here be very careful, useful output power. Don't write only total output power. Useful output power over, and this is power, so we will write power. Total input power times 100%. And then check. Write the values. My useful output power 1135 watts. So you can write the same, or even you can write 1100 watt. So 1100 divided by total, which is 3400 times 100. So as you will simplify, roughly it will be equal to 32%, my dear friends. So always remember that this numerator value will be smaller, denominator value will be larger, because no machine or device is 100% efficient. So then you said 33.38. Why I'm writing then 32? Maybe wait. Let me check again. Dear friend, 1100. Oh, sorry. Divided by 3400 times 100. 32.35, my dear. If it is 11.35, so it 32.35, so it's okay, 32%. Describe how useful energy may be obtained from geothermal resources. Geothermal. First of all, this is a renewable source of energy. Geo for earth, thermal, heat. So the thermal energy which is inside the earth. thermal energy which is inside. So what is done? There are two pipes. I explained you already this thing. One pipe is carrying the energy down, deep down, and then that is heated by the hot rocks into the crust of the earth. So that water is converted into steam. Okay, that steam then rises up and it is used to heat buildings or whatever, turn generators, turbine to generate electricity anyway. So first of all, this is geothermal resources. My dear friends, we can say okay, water is pumped into the earth and water is heated up by what? By the hot rocks. This water is converted to steam. Water is converted to the steam, and this steam is used to turn on turbines, turn on turbines or generator. You can say turbines. Okay, turbines will turn on the generators, not on turbines, to generate what? Electricity. Now, I cannot go forward by telling before without telling you a few things. Now, see here. There is one query that is from Zen. Okay. Now, here, my dear friends, I want to share something. There are some resources, very common question. Energy resources based on sun. I just want to say it again. Energy resources based on sun or solar energy. So they are, my dear friends, number one, of course, solar energy directly. Solar E for energy. Number two, wind energy. Number three, of course, fossil fuels energy. Number four, hydroelectric, hydroelectric power station energy. Number five, biomass or biofuel. So at least these three or four are based on sunlight. And I'm writing also one thing more. Please attention. Which are renewable sources here? This solar energy is renewable. No, wait. It is, but I will choose a more prominent color. This is renewable. Wind energy is renewable. Renewable energy resource which can be quickly replaced. Recycled. So wind energy is renewable. Fossil fuels, non-renewable. Hydroelectric, renewable. Biomass, biofuel, they are also renewable. Okay. Now, energy resources not based on not based on sunlight or sun, better to say sun, not based on number one, nuclear energy, my dear. Number two, like we did up there, geothermal. Number three, tidal, tidal and wave energy. Okay, now among these all, see, nuclear energy, this is non-renewable. Geothermal, that is renewable, it is available a lot, thermal energy is available. Tidal, it is renewable also. Please remember, this is just linked to that. Now, a rectangular glass tank contains 3 meter cube of liquid.
What's
So it
tidal
means,
energy?
sorry, my dear son. Yes, please.
What's tidal energy?
Tidal energy, my dear son, on particular days, especially the full moon nights, the let me say quickly, the net gravitational force is towards moon, directed towards moon. So in some parts of the oceans, not everywhere, some part the waves are rising up. They are higher than their normal height. They are technically known as tides. So the energy stored within them, that is tidal energy. So this tidal energy, it is based on moon. Geothermal, inside the earth heat. Nuclear, energy stored into the nucleus. Okay, the mass of the liquid is given, that is 2800 kilogram. Calculate the density. This is Sadka Jaria from Cambridge. Density is mass over volume. So 2800 over 3. So I'm just writing the answer directly. And this is, my dear friends, rounding off 930 kilograms. 930 mean rounded off answer, kilogram per meter cube. Why kilogram per meter cube? Mass is in kilogram and volume in meter cube. Next, a metal block is placed in the tank and it sinks to the bottom. Of course, its density is more than the density of the water, or that whatever the object wherever it is placed. Liquid, sorry. The top surface of the block is 1.1 meter below the surface. See, this is 1.1 meter below the surface. Figure, this top surface of the block is below the liquid, sorry, surface of the liquid. Figure 4.1 shows the block on the bottom of the tank. Calculate the force exerted by the liquid on the top of the block. Force. Here, first of all, we will calculate the pressure of the liquid, and then we can easily calculate this force. Now, my dear friends, how many marks? 4 marks. There is a reason for that. First of all, we can calculate the pressure. The pressure in fluids is equal to rho g, and it is just because of the change in density. Rho gh. So density we just calculated, that was 930. Value of g 9.8. See the difference in height 1.1. As we simplify it, we are getting the answer almost 10,000. 10,000 Newton per meter square. Now, we need to calculate area. That will be equal to length into width. Area of this block. So we can say 0.45 times 0.30, and basically the good thing is this is in meter, this is also in meter. So that is basically equal to 0.14 meter square. Why did we calculate the area? We know, my dear friends, we know that pressure is equal to force per unit area, and we need to calculate this force. So when we will cross multiply, force will be equal to pressure times area. So pressure we have already calculated. We need the area also. So that's why 10,000 is the pressure and area is 0.14. So as we will simplify, these are all rounded off answers. So my dear friends, answer will be equal to 1400 Newton is the force exerted by the liquid on the top of the block. So 4 marks. Maybe 1 mark for this one, 1 mark for this one, 1 mark for this formula, and 1 mark for the final answer. 1400 Newton. In this way, 4 marks. So do it step by step. Don't try to be professor and solving it all together. Okay. Now, next, my dear friend. So this is train track. Figure 4.2 shows the part of a steel railway track, and see there are gaps, small gap, section of the rail. There are small gaps between the section of the rail. This is already done by us in our MCQs booklet. State why the gaps are needed between the section of the rails. Explain your answer in terms of particles. In terms of particles. Uh, it prevents the bending, even buckling. I told you what is buckling, zigzag bending of track. When? No explanation. In hot weather, particles gain kinetic energy. Particles gain kinetic energy and move apart, or you can say take more space. So when track is fixed, so it will become what? Buckling mean like this. This is buckling or bending. So track is strongly, firmly fixed with the ground. So length will be increased. So if these gaps are not there, so the track will be bending and buckling, whatever you want to say. Quite simple question. This now next one is figure 4.3 shows a saucepan of boiling water on the heating ring of an electric cooker. The handle is made from plastic. Explain why this material is suitable. Very simple question and very simple answer. My dear friends, plastic is a insulator. So plastic is an insulator. So handle will not get too hot. So the handle will not get too hot to touch it. That's what. Okay. So then, my dear friends, next is will not get too hot to touch. Let's move to the next question. Now, electromagnetic waves have many uses. This is coming very commonly, and I shared with you already one small key electromagnetic waves page. So over there, all the things are written. On figure, draw one line from each use to the region of electromagnetic EM spectrum it use. So security marking, they like the nodes, currency nodes, my dear friends. So security markings, this is ultraviolet. Optical fiber, that is always infrared. Bluetooth, they are the radio waves. And detection of cancer, of course, gamma rays. recall memory. You have to memorize it and do it. State one advantage of using microwaves compared with radio waves to transmit mobile phone, cell phone signals. I already told you that uh, they require a short antenna and also can pass through the atmosphere, so can transmit large amount of data at high speed. So any one point you can write. So I will be writing microwaves can pass through the atmosphere. Microwaves, that's what is in my keynotes also. Microwaves can pass through atmosphere. Microwaves can pass through atmosphere to the satellites, which are many kilometers, thousands of kilometers away from Earth. So that's what only one mark fits. Okay. Dif Difference between the transverse waves and longitudinal waves. Well, this is not a big issue. I'm not going to write. I'm just saying oscillations or vibrations are right angle or perpendicular to the direction of the energy transfer direction of the wave. This is in transverse. In transverse waves, particles are at 90-degree to the direction of transfer of energy, and in longitudinal waves they are at 0-degree, are in the same direction as the direction of transfer of. And longitudinal waves have only one pet example, my dear friends, if you ask me, that is sound waves, or waves in a spring when it is compressed or stretched. Transverse waves, all electromagnetic waves are transverse, water waves are transverse, light wave, mean many examples. But I want to give you one more thing. Seismic waves, SEIMIC, seismic waves, which are earthquake waves. This is coming very commonly. There are two types. P seismic waves. Please remember, my dear friends, if it is P means primary seismic waves, they are longitudinal. Longitudinal. There are also S seismic waves, which means secondary seismic waves. These are earthquake waves basically. They are, dear friends, sorry, they are transverse. Okay, remember this. Rest definition you know. And physics of waves definitions are not into the definitions notes, which I shared with you 4 or 5. You can just check it from the block of physics of waves. First two pages are all key definitions. Now let's move forward. Figure 5.2 shows a simplified diagram C of a P seismic wave traveling through the earth. The paths of the wave are curved. Seismic waves are produced by rock movements in the earthquakes. Earthquake occurs here, that is the epicenter. Epicenter. This is solid mantle, X liquid outer core, inner core, and P waves are there. State the type of the wave that P waves can be modeled as. I told you already. So P waves are what? My dear friends, P waves are longitudinal waves. If they are longitudinal waves, it means their vibrations or oscillations are in the same direction to the direction of transfer of energy, or in the same direction as the direction of travel of the wave. At point X, they showed this point X. P wave travels from solid mantle to liquid core. It means density is changed. It means speed is changed. There is a sudden change in direction. You can see sudden it was going this way, but now it is moving this way. Sudden change in direction of the path of the wave. Explain the change in direction of P wave at point X. It is refraction, which is caused by the change in speed. It is refraction. Just looks like it will be very difficult question, but if you are conceptually strong, no problem. And it is very clearly mentioned. See, at X, this is at the boundary of inner core and liquid outer surface. So, and this is, see, this is solid. Here it is solid and here it is liquid. So density changes. So speed changes, and change of speed causing the refraction. It is refraction, 1 mark, caused by, my dear friends, caused by the change in speed. Caused by the change in speed. Change in speed of what wave? Change in speed of the wave. Seismic wave, or simply you can write wave. And very careful. See, in case of refraction, direction changes. And that's what I have mentioned here. And I have told you people. Any question, any query, please feel free. You people can ask me. Okay, my dear friends, let's see next question now. The Earth's surface absorbs incoming radiations from the sun and also emit thermal radiation from the from its surface. Thermal radiations from its surface. Okay, so over the past 50 years, scientists estimate the average temperature of the Earth's surface has increased by approximately 0.75 degrees Celsius. Explain what is causing this average temperature rise. Average temperature rise. So here trapping of the heat will be involved. Greenhouse gases. So it is caused by it is caused by increase in greenhouse gases like carbon dioxide and methane and like this. Greenhouse gases in the atmosphere. Why these gases are in, this is 1 mark, okay? Why these gases are increased? So it is in caused by this greenhouse gases are trapped and cannot escape, and they cannot escape into the space. Where? Into the space. So this way you can answer this question, that is on physics of waves. My dear son, Ahmad Murta, exactly you are right, but always try to play safe. Why to say increase or decrease? When you are writing change in speed, so that is perfect. If it is increased, this is correct. If the speed is decreased, even that is correct. Okay, so if your answer is okay because it is moving from liquid to solid, so sound wave speed is increased. You are right. In gases, sound waves are moving slowest. In liquids, medium like 300 to 350. In general, we are seeing for speed of sound in gases, almost 1500 in liquids on the average and 5000 on the average in solids. So instead of saying increase, why not to say change in speed? That is more safe and it is correct answer. And also be very careful, very careful. The examiner is asking to you to write the speed of sound in air. Mostly students are writing speed of light in air, which is 3 times 10 to the power 8 meters. Read the question carefully. Whatever the speed is asked, only answer that. No electricity started. Figure 2.1 shows a circuit which includes an LDR light dependent resistor here. Voltmeter is connected across LDR. 400 ohm fixed resistor. LDR is basically a sensing resistor. Its resistance, just I'm writing the resistance of LDR is inversely proportional to light intensity. I'm writing for easy understanding light level. So the LDR is brightly lit room. In a brightly lit room, it means its resistance will be less. The voltmeter reads 1.8. So here how much? 1.8 volts. So what will be the volts here on 400? So 5 minus 1.8, it means 3.2 volts here. Remember it, because this is a series circuit. In series circuit, total voltage is the sum of the voltages, potential differences across different components. So 5 volt is total, 1.8 volt is across the brightly lit room with LDR. So it means 3.2 will be across this 400 ohms. So 3.2 plus 1.8, it will be equal to 5. Calculate the current in 400 ohm resistor. So see, already I did this job for you. So my dear student, first of all, you should write voltage across 400 ohms. That will be equal to V total minus V LDR across LDR. So just because 3 marks, so we should show this proof. So my dear, V total, that is 5 minus voltage across LDR, that is 1.8. So answer will be equal to, first of all, 3.2 volts. This is done. Then we need the current. Current in 400. So current in 400 ohm resistor, that will be equal to V across 400 ohm over R. So that will be simply 3.2 divided by resistance is 400. So as you will simplify it, we are going to get the answer 0.008 0.008 amperes, or you can write 8.0 times 10 raised to power minus 3, and don't forget to write ampere. Why minus 3? Minus 1, minus 2, and minus 3. So this way, we are moving the decimal from left towards right. So whatever the number digits we will move right towards right, that number will be in the powers of negative powers of 10. No problem, Amin. No problem. This is a series circuit. How do I know series circuit? Because there is only one path the current can take. So this is, and current will stay same. Now see, even if he's asking in the next part, what is the current into the LDR passing through the LDR? So our answer will be same 0.008 amperes, because in series circuit, current stays the same. Current stays the same, but voltage in EMF of the battery is equal to sum of the potential differences across the different components. So only two components are there. One is 400 ohm resistor, other one is LDR. Total EMF of the battery or this power supply is 5 volts. He himself told that 1.8 volt is being consumed across, or it is across, better to say it is across the LDR when there is a bright light into the room. Now, what will be the share of potential difference across 400? So 5 minus 1.8, mean if I'm writing it here, my dear son, so 5, I'm calling this V1, this one as V2, is equal to V1 plus 1.8. So when I will make V1 as the subject of equation, so 5 minus 1.8, 3.2 volts. So that's what I wrote. He wants the current in 4 ohm resistor, 400 ohm resistor. So first of all, 3 marks. Show the examiner. This is 1 mark. This is the second mark. Let me say this all, and this will be the third mark. So whatever I did there, just show voltage across 400 ohm is equal to V total minus V LDR. So 3.2. Then current across not across, through 400 ohm resistor, that will be by Ohm's law V over R. So V is 3.2 across 400 ohm over 400. So you are simplifying it and getting the answer. Please, my dear son, Amin, comment on this. So you have to be very careful about series and parallel combinations. So this was series. I would like to write here something about parallel. For parallel resistors. Shortcut basically for the resistors connected in parallel, total current or current in the circuit, current in the battery will be the sum of the currents in the branches. I1 plus I2 plus I3, so on. But in this case, V total will be equal to V1, that will be equal to V2, that will be equal to V. Potential difference across each component will stay same. One thing more, total resistance in parallel, simply 1 over R1 plus 1 over R2 plus 1 over R3 all raised to the power of minus 1. All raised to the power of what? Minus 1. This is for total resistance in series circuit, parallel circuit. What about series circuit? Again, let me write for resistors in series. For resistors in series, V total, which is also we can say EMF, that is equal to V1 plus V2 and so on. Second point, total current, which is the current in the battery, that can be equal to I1, that is equal to I2, and we can say all the currents are equal to I because they are same. And total resistance, third point, that will be simple sum of the given resistors. These are some three basic points. Then if in series circuit, if one component is off, all components will be off because there is only one path for the flow of current. And in parallel circuit, if one component is off, the other components will still be working because there is still regular path available for them. Then, my dear friends, now the light level in the room changes from bright to dark. And I told you already, resistance of LDR. Light level is decreased, so resistance of LDR will be increased. State explain the effect of this on voltmeter reading. Increases. Why does it increase? I'm going to give you the explanation now. The resistance of LDR increases. And so potential difference, or better to write share of potential difference. Share of potential difference across LDR increases from battery, better to say from battery or power supply across LDR increases. And key point for this, always remember in series and series circuit or potential divider, V is directly proportional to R because current is staying here what? The same. So in this way, 3 marks, and very common question, very common question. Then next is, now see here, diodes are there. So forward and reverse bias concept should be in our mind. So positive terminal of the battery is connected to positive side of the diode. See, this is positive and this is positive. So this diode will be forward biased. It will give out light. So like this, okay? So figure 6.2 shows two light emitting diodes, LEDs, connected in parallel in a circuit R. Circuit R is a red LED and G is a green LED. R for red and G for green. The voltmeter across LEDs shows the potential difference of 2 volts. Potential difference of how much? 2 volts. So they are in parallel. So here it will be 2 volt and across this one is also be 2 volts. Figure 6.2 shows a current potential difference graph for LEDs. Now remember, current said first, it will be in on y-axis and see milliamperes. It means times 10 raised to power minus 3 amperes. And potential difference, that is in volts, 3 volts. On figure, use the current in the ammeter. Current in the ammeter. So total current we have to calculate. And how many marks? This is 2 marks. So what to do? Current in the ammeter. R and G. R and G. So we will use 6.3 figure to calculate the current in the ammeter. So ammeter is giving us the total current. So whatever the current is across red, so we will calculate the current across red, we will calculate the current across green. So we will add them up together. That will be the current in ammeter. So here it is 2 for green. So my dear friend, current in green LED is this. So see 20. So 2, 4, 6, 8, 10, 12. This is 12 milliamperes current in green. Current in red, see, we will keep on moving forward. See, it touches the graph here. So what is the value? My dear friends, that is 42 milliampere. So what will be the total current? Total current will be equal to current in the green LED plus current in the red LED. So green it is 12 and red it is 42, but unit is milliamperes. So my dear friends, it will be equal to 60 milliamperes. And why so? Let's see the diagram. So emitter is in series, gives the total current. So when we are adding up the current of these two, so they are becoming in series with this resistance. So whatever is the current here, same current will be here in the resistor, same will be in the emitter. So my dear friends, this is so much important. So much important. Calculate the current from the figure. They told by them, use the figure. So voltmeter reading is 2. So we will mark where it is 2. So at 2 volts for green, current flowing through it is 12 milliampere, and at 2 volt for red it is 42, because each small scale is representing 2 milliampere, because 20 minus 0 divided by 10. So each small scale represents 2 milliamperes. And diodes were forward biased. If we will reverse the battery, when it is forward biased, when the positive terminal of the battery is connected to the positive side of the diode, this side of the diode is positive. Either it is LED or simple. So diode forward bias, current flows. Either battery is reversed or diode is reversed. Mean direction is changed. Any one, they will become reverse biased and no current will be flowing through them. So the connection to the power supply are reversed. Mean that's what I was saying. This is made negative, this is positive. So negative is connected with positive. Diodes will become reverse biased and no current will be flowing through the emitter. So it will be 0 ampere. Okay, my dear friends, let's move forward. Any query, I can go back. This is no AC generator question. Simple AC generator, because there are two slip rings, brushes are there, coil is there, handle is there to turn on the generator, and the north and south poles are there. Explain the function of the slip rings and brushes. This is a recall memory. Slip rings, they provide whatever the output voltage is given. So they provide us the provide slip rings and this. So my dear friends, you can write any answer. I'm writing they. They provide continuously, continuously connection. What? Between the coil and the lamp. See, this is the coil and lamp. This is continuously connected. Even the coil is rotating. So see, it will be rotating within this here. And brushes will keep these slip rings in their place. So what will happen? There will be a continuous connection between the coil and lamp. So they provide continuously connection between coil and lamp. Just observe the diagram and give the answer. Describe how an alternating current is generated in the lamp. Now we have to say that there will be magnetic flux changing or magnetic field lines are being cut when the handle is rotated. So all this we will be writing. When the handle is rotated, or you can say turned. Or you can say when the coil is rotated. Coil is rotated or turned with the help of handle, like this, with the help of handle. No, this is one mark. Now let me change the color. So coil cuts the magnetic field lines, and third mark, EMF is induced. EMF is induced, causing AC means alternating current. Like with just the Faraday's law of electromagnetic induction, which is not exactly the part of our syllabus, but we know whenever there is a relative motion, because mean the distance between the coil and magnet is continuously changing, so field lines are being cut, magnetic field is changing, which is causing an induced EMF or alternating current. State two possible changes that cause a larger maximum current in the lamp. So increase the number of turns. This is a recall memory. Repeated question, increase the number of turns, use stronger magnet, turn the coil faster. Any two of them you can write. Any two of them you can write. I will be writing use a stronger magnet. Stronger increase the speed of rotation. What will happen? So speed increase the speed of rotation of coil. This will make the change of magnetic field lines or changing magnetic field faster, or it will make the more number of lines will be cut per unit time. So something like this. So increase the speed of the rotation of the coil. Number three, increase the number of turns. Number of turns, better to say in coil also. Sometimes why I wrote all three, sometimes they are giving, okay, one is already done. So what are the two ways? So that you can write this. So this was also a simple recall memory. Now see, this is alternating current. So figure shows a graph to show how the electromagnetic force varies with time of the coil. Determine how many revolutions the coil has made from O to E. How many revolutions the coil has made from O to E? Okay. Yes. Revolution, complete cycles. 1, 2, and half. So 1 plus 1 plus 1 plus half. So we can say 2.5, my dear friends. Very simple. Just count the number of cycles, revolutions. Then next is figure shows the end view of the position of the plane of the coil at time t is equal to 0. The coil is rotating anti-clockwise. See this way, and it is shown also. On figure, draw 4 lines to match the coil position to the times A, B, C, and D. The coil is viewed from the front. Coil is viewed from the front. So you can see here north, south, and these are the positions of the coils. 4 lines. Now when it is at A, this one A, see at A maximum EMF is there, and maximum EMF when the coil is horizontal. When the coil is what? Horizontal. So my dear friends, this much. Then B, let's go back. B, at B, magnetic field is 0. It means when the coil is vertical. Where is the coil vertical? Oh, sorry, check here. Coil is vertical here, so B is like this here. Then point C. Let's check what is C. What is C? C is again when the magnitude of the EMF, you can see it is 0. So it will be again vertical. So C will be again the same position. Now D. Let's check what is D. At D, my dear friends, again maximum. So what to do? Maximum when the coil is horizontal. Very many times we discussed this question. So again, this one. So when the maximum, now see why I'm saying this. Please remember here, my dear friends, what I'm going to share. See these coils. When the coil is horizontal, see the lines of the force being cut are maximum. So these are the lines of force. This is the coil position when it is horizontal. So see this way. When the coil will become vertical, so see the gap will come. What I'm saying, see right now here, my dear friends, wait a minute. Let's go back to the original diagram in the beginning. Yeah, here. See right now, coil is horizontal in this case. So maximum lines will be cut by this coil. So magnetic field, change of magnetic field will be maximum. EMF induced will be maximum. That's why peaks are there. But when the coil will become vertical, see there will be a gap like this. So lines are not being cut. See, these are the lines. They are not being cut. They are passing. So electricity generated will become 0. So that's why when the coil is horizontal as it is shown, EMF induced is maximum. When it will become vertical, so the lines from north to south will not be cut by the coil, they will be passing through the coil. So lines of force must be cut. That's what I wrote even in the answer. The magnetic field lines are, wait a minute. Magnetic field lines are, the coil cuts magnetic field lines. So A and D, A and D amplitude, sorry, EMF is zyada, maximum. At B and C, 0. So when 0, check it should be vertical. So that's why at 0, B and C. So I choose vertical. Coil is vertical. And at D and A, horizontal. That's what is the, and 3 marks you can score easily. Then, my dear friends, now of course, nuclear. and the formula question, alpha particle. So alpha particles are directed at very thin sheet of gold foil. Alpha particles are positively charged. Their charge is +2 of element mean 2e. They are heavy. They are highly ionizing. They cannot penetrate through even paper. Highly maximum ionization and least penetration. So remember, ionization and penetration mean passing through. These are two Billuck's opposite properties. Alpha particles are highly ionizing, maximum ionization of the alpha particle. So they use most of their energy in causing ionization. They are not left with enough energy to penetrate through the matter. And even in air, they can travel only 5 centimeter maximum, and then they will ionize the air and arrive, disappeared. Beta particle, electrons emitted from the nucleus. Quickly, I'm sharing. They are in medium in case of ionization, in case of penetration. They can pass through paper, they can pass through plastic, rubber, but they are stopped by thin aluminium, thin metals, few millimeter of metals. Gamma, electromagnetic waves, no charge, no mass. Alpha, they are deflected by electric and magnetic field, but less because they are heavy. Beta, they are also deflected by electric and magnetic field, but zyada because they are less in mass, lighter. Gamma, they have no charge, they have no mass. They are always going straight without any change in direction, without any deflection. And we can use Fleming's left-hand rule to find the direction, which direction they will go. And gamma has no charge, they have no mass, so very least ionization. So they are not wasting their a lot of energy in causing the ionization. So they are left with enough energy so they can penetrate maximum. They can pass through paper, they can pass through plastic, rubber, thick metals. They are only stopped by or slowed down by thick lead or thick concrete. So that was general discussion about the properties of alpha, beta, and gamma. The following observation provide the evidence, the nuclear model of the atom. What conclusions may be made about the model of the atom from these observations? Now, first of all, observation. Most of the particle pass straight through the foil. Conclusion. They are not affected by, they are not troubled by any matter. So it means most of the atom is empty. Most of the atom is empty space, or nucleus is very small as compared to the atom. So one point you can write, most of the atom is empty space, or nucleus, which is solid part, nucleus is very small as compared to atom. Any one of these 2 points you can write as compared to atom itself. Observation. A few particles bounce back or reflected through the large angles. It means there is something solid, which is nucleus, because reflection is only in case of high density. So I will say that most of the mass of an atom is concentrated in the nucleus. So it means when it is bouncing back, they have hit the nucleus and they bounced back. But this ratio is very small. Now see here, very easy to understand now. Figure 8.1 shows 3 beams of ionizing radiations, alpha, beta, and gamma, passing between 2 parallel plates. Of course, they are charged plates. The plates are charged and there is a uniform electric field between the plates. So, student explain which path P, Q, and R shown a beam of alpha particles. See, I told you already. This gamma, just I'm answering it. Alatul, gamma is this one because they are not affected by electric and magnetic. Beta is deflected the most. This is the beta particle because they are lighter. And this is alpha particle because they are attracted towards positive, negatively charged plate, and their deflection is smaller as compared to beta The reason for that, they are very heavy. So the path of the beta is T. Sorry, not beta. Sorry. Alpha. Alpha. So that is what? Alpha particles are deflected less as they means alpha particle. They have greater mass. That is more than enough for 2 marks. Then, still explain the direction of electric field between the plates. The alpha definitely moving towards negatively charged plate, and this is positively charged plate. So electric field lines will be going from positive towards what? Negative. So direction of the electric field is upwards. Direction of electric field lines is what? Upwards. Why? Because alpha, it is deflected upward. Alpha is positively charged, so it is deflected towards the negative plate. Okay, or even we can say beta is negatively charged, so it is deflected towards the positively charged plate. Anyway, you can write. So I will write for alpha. So explanation is, and mostly the directions and this electric field we are defining with positive charge. So that's why I'm writing for alpha particle. So the electric field is the force on unit positive charge. That's what. So alpha is positively charged. So alpha particles are positively, I wrote shortcut, positively charged and deflected or attracted and are attracted by negatively charged plate. Negatively charged plate. That is enough. So upward plate is negative, downward will be of course positive, and the electric field is always from positive towards negative. Curium 242 is radioactive isotope. It emits alpha particles. It has a half-life of 160 days. After 480 days, the mass of the curium in a sample is this much. Calculate the initial mass of curium. No problem at all. First of all, we need to calculate the number of half-lives. Number of half-lives. How to get? N is equal to, I'm just writing it so that you can understand what is N. N is the number of half-lives. How to get? Total time, which is 480 days, and be careful, the units should be same. Days. 160 days is the time of one half-life. As you will simplify it, answer will be equal to 3. 480 divided by 160, answer is 3. So 3 half-lives. No, he does not want what is the half-life in future. How much will be left? He's asking in past. So if it is in past, instead of dividing, we will multiply. So you know what I'm going to do now? Please remember this. This is even in February, March, the same thing came. They are not asking in the future. So if he was asking how much will be left after 3 half-lives after 480 days, we were going to do every time 2.4 divided by 2, then whatever the number divided by 2, whatever the number divided by 2. Here, initial mass, it means in the past. So what to do? To get the initial mass, my dear friends, see what is the mass right now? 2.4 times 10 raised to power minus 3 multiply by 2. It will be equal to how much? 4.8 times 10 raised to power minus 3. This is one half-life count. Now second half-life, see, 4.8 times 10 raised to power minus 3 multiply by 2, because we want to get some number in past, because we need initial value. So that will be equal to 48 to the 9.6. So 9.96, sorry. So 9.6. This is grams, this is grams. Now, my dear friends, the final answer, third half-life. So 9.6 times 10 raised to the power minus 3 multiplied by 2. It will be, my dear friends, 1.92. 1.92 times 10 raised to power minus 3 grams. So initial mass will be, you can round it off to two significant figures. So 1.9 times 10 raised to power minus 3. And don't forget to write grams. See here, dear friends. This is first half-life. This is second half-life. This is third half-life. So 3 half-lives before, it will be 1.9 into 10 raised to power minus 6. And also they want initial mass. Initial mass will be greater. So if we will keep on dividing, it will become less. Initial mass means we have to move in the backward direction in the past. So instead of dividing, as we are doing to get something in future, so to get something in past, instead of dividing, we will keep on multiplying. How many times? According to the number of half-lives. That's what. Now let's move to the space physics. This is C, repeated question. Cosmic microwave background radiations can be observed in every direction in space around us. State when CMBR was produced. When the universe was formed, at the same time they were formed. So they were produced, or you can say, let me write that, when the universe was formed, or shortly after the universe was formed. Recall memory. Explain how the wavelength of this radiation has changed since it was formed. It is stretched simply. So wavelength lambda of CMBR has been increased. Why? Because the universe has been expanded. Is increased. Why we are writing this? It is because universe is expanding. 2 marks, so 2 valid points we have written. Now see here, this table is there, and figure shows the data about the planets in our solar system. Temperatures are given, or time for one orbit, Earth, years it is given, Venus, Earth, and all this, and the radius is given. The orbit of the Venus is approximately circular. Calculate the average orbital speed of the Venus. Give your answer in kilometers per hour. No problem at all. So this formula, very common, too much repeated for orbital speed. That is, my dear friends, V is equal to 2 pi r. R is the orbital radius over T. Answer should be in kilometers per hour. So 2 pi times r. It is for Venus. Venus is 108 kilometers. 108, but see, times 10 raised to the power of 6 in kilometers over T. Orbital radius is 0.62. That is in years. And we have to write the answer in what? In hours. So, my dear friends, 0.62. Each year has 365 days, and each day has 24 hours. Bus up to here. A reason for that, because we need answer in hours, not in seconds. So when we are simplifying, roughly 120,000 kilometers per hour. So this is what? This is in kilometers per hour. So here I'm writing per hour. So 120,000 miles. Okay. Show that the average surface temperature of the planet changes as its state. How? Sorry. Average surface temperature of a planet changes as its distance from the sun increases. So what happens to the average temperature? You can check the table. Here see, as the distance is least, temperature is maximum, and as the distance is increasing, temperature is what? Decreasing. So simply how? Simply say it decreases. No need to go in a lot of detail, my dear friends. So this was quite simple question. Now question number 10. Sketch a diagram to show the orbital path of the comet around the sun. Mark the position of the sun on your diagram using an S. You know, comet, it has an elliptical path. A perfect elliptical path for a comet. So, oh no, not this way. Something like this, and you can write sun is here and comet anywhere. You can say like this is comet. By the way, they did not ask for to draw the comet. Draw a cross on your diagram to show where the comet is traveling with the slowest speed. Label this X. Okay, no, then I should rub this and just draw a cross. So when this is closest to the sun, so oops. Sun is here, so that is labeled as. Explain why the speed of the comet changes as travels around the orbit. 3 marks. Use the law of conservation of energy in your explanation. So first of all, we will say, my dear friend, that the energy, total energy stays constant. Did I write it correctly? And you are all muktabans, wallahi. Here, the speed will be fastest. They want the slowest speed, my dear friends, and you are all sleeping. Oh, I think tired. So what to do? It should be over here when it is furthest away. All sleeping. So anyhow, so energy is conserved. So, and energy is in two forms. My dear friends, what are the forms of energy? So total energy is equal to potential energy plus kinetic energy. This is the first mark you have stored. Now, second, either you can go with energy or you can go with kinetic energy or potential energy. So we can say when the comet is closer to the sun, it has greater speed. So its kinetic energy is maximum and potential energy is EP for potential energy is minimum, but the total will stay the same. So like this way, you can say okay, let me write minimum. It has greater speed and minimum. Like this, 3 marks you can score, and this whole paper is done, my dear friends. And you have, yes, you are right. You are right. So this is the paper. I'm wishing you best of luck for tomorrow's exam. But still, I'm telling that 10 a.m. to 11:30, I will be available tomorrow morning. Any doubts you have, you can. Otherwise, I will be just solving one paper like this. And again, then in a second term after Juma prayer, 12:30 to 1:30, again I will be available for your doubts. Stay blessed. And if you have any question, you can ask me. Thank you.